Hello students, welcome back to my channel. Today again I have come with a video. This time I have picked questions from gravitation and rotational dynamics which were asked on 30th of January 2023 JEE mains. I have combined, as I have already mentioned in the earlier videos also. This time I have combined the morning and evening session questions together and I have created videos, okay? Next to each question, you can see there is a mention of the thing whether the question was asked in morning or evening. Okay. So without wasting time, let us start the question discussing this. So here we go. The first question is this: if the gravitational field in space is given as this, taking the reference point to be at r equal to 2 cm with gravitational potential V equal to 10 joule per kilogram, and the gravitational potential at r equal to 3 cm in SI unit. Okay. Now students see here, suppose I take R axis as x axis. So as per the question, the field is in the negative direction, so this way. Okay, as you know, field lines are always directed from higher potential to lower potential. In other words, as you move towards positive R direction, towards right, potential will increase. Okay. So at some point, let us say R equal to 2 cm. The potential is 10 joule per kilogram. Now at R is equal to 3 cm, certainly potential will be greater than 10. So these two options have been eliminated. Whenever you go against the field, potential increases. And if you go in the direction of field, potential will decrease. So we are left with options B and D anyway. So the basic formula states minus dV by dr, that is negative potential gradient, is equal to the field. It can be electric field or gravitational field depending on that situation. So we can write this as minus k by r square. This is given, no? This is given. So now this is a variable separable differential equation. Separating the variables, minus will get cancelled here, both sides. Minus minus gets cancelled. Separating the variables, we have this. Okay. Now integrating both sides. When R is 2 cm, potential is 10 joule per kg. When R is 3 cm, we want the new potential. Let us name the potential as V. So therefore, we have integral V integrated between limits 10 to V is equal to K into, this will be minus 1 by R integrated between limits 2 cm to 3 cm. Students, I am carrying the unit centimeter because mostly we are proceeding in SI units, but this is CGS unit. So let us keep this as centimeter. And K is given in mixed unit, both SI and CGS mixed. So let us see what happens. So we have V minus 10 is equal to minus K into 1 by 2 minus 1 by 3. Sorry, 1 by 3 minus 1 by 2. I'm sorry. Upper limit minus lower limit. So V will be equal to 10 plus K by 6. So this is 10 joule per kg. Okay. Remember these are in centimeters. This will be per centimeter. Okay. Per centimeter, because the numerator 1 centimeter will get cancelled with the denominator, and in the denominator we are left with 1 cm. So the value of K is 6 joule cm per kilogram divided by 6 cm. So 6 cm gets cancelled, we are left with 1. So 10 plus 1, that is 11 joule per kilogram. So that is SI unit. So SI unit. So D option is the correct option. Moving on to the next question. An object is allowed to fall from a height r above the earth, where r is the earth's radius, its velocity when it strikes the earth. Now, students, even though we'll apply law of conservation of mechanical energy, which states that loss in gravitational potential energy gets converted into gain in kinetic energy. But please don't use the formula mgh, because the formula mgh is supposed to be used only when height is very small in comparison to the earth's radius. When h is very small in comparison to earth's radius, only then loss in potential energy can be calculated as mgh. That is an approximate formula. Whereas here in this question, as you can see, that the object has been dropped from a height equal to r, where r is the radius of earth. So certainly g is not constant here. So if g is not constant, acceleration due to gravity, then you cannot use the formula mgh. So we have to go with the actual formula. So let us see what is the actual formula. So this is the earth, and draw two different earths for two different situations. Okay. Now in the first situation, it is dropped from a distance equal to r. Remember, initial velocity is 0. This distance is r. And finally, we have to find the velocity with which it strikes the earth surface. Okay. So I'll be applying law of conservation of mechanical energy for these two situations. For the first situation, total energy is kinetic energy is 0 and potential energy is minus g. I'll take the mass of earth as capital M, mass of the object as small m, so capital M small m by 2r. Remember, distance of the point from the center of earth that you have to take. Whereas here finally the total energy is again kinetic plus potential. Kinetic energy of the object is this. Remember, we are solving this problem with earth as a reference plane. So earth is supposed to be at rest. So earth has no kinetic energy, okay? And potential energy will be minus g mm by r, because now the distance from the earth's center is, the distance of the object from the earth's center is r. So we can equate as per law of conservation of energy, total energy remains constant. So when we equate this, we have minus g capital M small m by 2r is equal to half mv square minus g capital M by 2r. So I'll separate this separate. Small m gets cancelled here. So always remember, while solving a question, particularly while solving an equation, mathematical equation, try to cancel out what all things can be cancelled. Then multiply throughout by 2. Then we are left with v square equal to, when when you multiply throughout by 2 and take this to this side, you have 2 gm minus gm by r. So gm by r. I hope you understood this. I multiplied by 2 here, 2 got cancelled. Again I multiplied here with 2, 2 got cancelled, and here there is a 2. So this 2 minus 1 is this. Now we all know that acceleration due to gravity is gm by r square on the earth's surface. You can see the options are in terms of small g. Can you see? So accordingly we have to express our answer in terms of small g. In other words, capital Gm can be replaced by small gr square. So we have small gr square, 1 r gets cancelled here, and we are left with v equal to under root gr. Okay. The second option, B option. Moving on to the next question. A thin uniform rod of length 2 meter, cross section area A and density D is rotated about an axis passing through the center and perpendicular to its length with angular velocity omega. If value of omega in terms of rotational kinetic energy E is this much, then the value of alpha is. It's very simple and straightforward question, students. You have a rod of length 2 meters. It is rotating about an axis passing through its center and perpendicular to its length. So rotational kinetic energy is half I omega square. Is it? Rotational energy is half I omega square. Now m and moment of inertia is ml square by 12. Be careful about the axis. As you can see, the axis passes through the center and is perpendicular to the length. You have to use ml square by 12. Okay. Now instead of mass, they have provided some other information, that is cross section area and density and all. So mass can always be written as volume into density, and volume is cross section area into length. So I'll replace m by ALD. So we have half into 12. Mass is A L D L square by 12. I hope we are proceeding in SI unit. Anyway, units have not been mentioned anywhere, but since the length of the rod is given as 2 meters, hopefully we have to get the result in SI unit. So let us substitute the value of L equal to 2 here. So this 12 extra. So half into 1 by 12 into A into D into 2Q is 8 into omega square. So 1 2 gets cancelled and 4 3s are. So finally we can rewrite omega square as 3e by AD. So omega will be under root 3e by AD. So this alpha is 3. Moving on to the next question. A uniform disk of mass half kg and radius r is projected with velocity 18 meters per second at t equal to 0 seconds on a rough horizontal surface. It starts off with a purely sliding motion at t equal to 0 second. After 2 seconds, it acquires a purely rolling motion. The total kinetic energy of the disk after 2 seconds will be. Now you know total kinetic energy means the kinetic energy corresponding to translatory motion as well as that due to rotatory motion. So total kinetic energy will be kinetic energy due to translatory motion plus kinetic energy due to rotatory motion. So now, as you can see, kinetic energy due to translatory motion is half mv square, okay, and kinetic energy due to rotatory motion is half I omega square. Now, at the end of 2 seconds, it starts purely rolling. Purely rolling means rolling without slipping, and whenever it does rolling without slipping, we can always have v equal to omega r. Okay, so that means I can write this moment of inertia omega can be written as v by r whole square. So in other words, we have to find v. Once we get v, things will be very easy for us to solve. So let us find v here. In order to find v, whatever information they have furnished, you see, the initial velocity is 18 meters per second. Initial velocity of the center of mass. Final velocity we have to find. Retardation we can know because friction is given. Naturally, the lower part of the disc will be rubbing against the surface. So the surface will be providing friction to slow it down. To slow it down and simultaneously to make it acquire angular speed also in the clockwise sense. Okay. So what is the retardation here? Retardation is nothing but frictional force per mass. Frictional force is mu into normal reaction. As you can see, normal reaction is balanced by weight. So normal reaction is balanced by weight. So you can see the retardation due to friction is mu g. Mu is zero point 0.3, g is 10. So retardation is 3 meters per second square. Now, since it is constant, we can apply equations of motion. So we have v equal to u plus 8. So final velocity we have to find. Initial velocity is 18, retardation is 3, and time taken is 2. So according to v is 12 meters per second. So it's a matter of substitution here. Okay. So therefore the total kinetic energy from here, we'll start from here once again, is half m v square plus half I is m r square by 2, and this is v square. V square is again 12 into 12. Okay, or I'll do one thing. If it is confusing, then let us keep it simple. Here itself I'll simplify. This will be half mv square plus I is mv square by 2 into v square by mr square, sorry, mr square. So r square gets cancelled. So this will be 3 by 4 mv square, half plus 1 by 4. So 3 by 4, mass is half, speed is 12 into 12. So finally we have 4 threes are 2 6, so 54 joule is the answer. 54 joule is the correct answer. Okay, that's all in this video. Thank you so much students for watching my channel. Please subscribe to my channel and hit the like button. Thank you so much.